In this set of problems, we know that a computer password consists of 12 characters and replications are allowed. So the first problem we want to solve is how many different passwords are possible if each character may be any lowercase letter or digit. So how many lowercase letters do we have? Well, that's 26. And there are 10 digits because it's 0 through 9. So always keep that in mind. A lot of times people will think 9 digits because 1 through 9, and they forget about 0. So 26 plus 10 gives me 36, and since there are 12 characters and repetitions are allowed, or replications, then we're going to take the 36 and raise it to the power of 12. So this is going to give us a really large number, and in scientific notation, once I put this into the calculator, it says 4.74, and there's a long decimal, E18. So what does this mean? This is scientific notation, and it means 4.74 times 10 to the power of 18. So that's our answer for part 1. Now we go to part 2, and it says how many different passwords are possible if each character may be any lowercase letter. So now we're only allowing letters, and we're saying no digits. So that will be 26, just the number of letters, to the power of 12. And that turns out to be 9.54 times 10 to the 16. And that's our answer for part 2. Now in part 3, we want to know how many different passwords are possible if each character may be any lowercase letter or digit, and at least one character must be a digit. So in the last one, we wanted no digits at all. And now we're saying at least one digit, a minimum of one digit, or possibly up to 12 digits. So this really covers everything other than no digits at all. So what we're going to do is we're going to take our answer from part 1, and that was 4.74 times 10 to the 18, and subtract 9.54 times 10 to the 16. This is a little difficult to enter into the calculator, so I'm going to show you an alternate way. But if you really want to enter it into the calculator just like this, what you're going to do is you're going to type in the 4.74 and then E, and the way you get the E is by pressing second, what is it, in the comma. So the comma is right above the 7 key. So if you press second and comma, then you get E. And then you just type the 18 minus 9.54 E16. So you can type it in that way and get your answer, which is, what, 4.64 E18. 4.64 times 10 to the 18. But what you could also do is just go back to the original computation. You had 36 to the 12 minus 26 to the 12, and that will also give you 4.64 times 10 to the 18. So either way, you can compute it that way. Now in part 4, a computer is generating passwords. The computer generates 12 characters at random, and each is equally likely to be any of the 26 letters or 10 digits. What is the probability that the password will contain all letters? So now we're looking for a probability that the password will contain all letters. So the probability of that Probability of all letters. How many ways are there to get only letters? Well, we said that was 26 to the power of 12. And then how many ways are there to get 12 characters in any format? And that was 36 to the 12. So if I divide those, I will get 0.0201, and that's rounded to 4 decimal places. So I just divide those. To enter the exponent on the calculator, you're going to type in 26 and then use the caret 12 and then just divide by 36 to the power of 12. And that gives you the decimal. And then in the last one, we want to know what is the probability of getting at least one digit. And this is really similar to what we did with the number of ways to get at least one digit. So we're going to say the probability of getting at least one digit is 1 minus the probability of no digits at all. And we already found that in the last problem. So this is just 1 minus 0.0201, and that gives me 0.9799. Because the probability of no digits is the same as the probability of only letters. So it's just a different way of wording that. So that's how we get our answers, and I hope that helps.